I can see attendees have started joining us. Attendees, thank you so much for taking out time from your busy schedule and joining us today. We just wait for 2 minutes more to start the webinar. Can I request my team to start playing the video?
The last 2 decades, we experienced the rise of Chinese photovoltaic companies and the transformation of LONGi from a pathfinder and an inventor of technology to an industry leader. LONGi was established in 2000 and changed the game rules of the industry by promoting monocrystalline modules in 2015. In 2016, LONGi's mono-PERC technology brought the industry into an era of high efficiency and low LID. In 2017, LONGi's bifacial PERC technology increases remarkable module power output with rare side irradiation. In 2019, M6 silicon wafers led the PV industry to an era of 450-watt ultra-high power. With strong innovations, LONGi has made numerous achievements like 24.06% efficiency of monocrystalline PERC cell, the highest production of bifacial monocrystalline modules in the world, continuous technology advances and LCOE optimization. Now, LONGi is about to set off another advancement in the industry once again. The latest LONGi high Mo5 modules with optimized LCOE, especially designed for large-scale PV stations, are now available. The power output of high Mo5 is up to 540 watts, with over 21% efficiency. The optimal size of the high Mo5 module, coupled with sophisticated construction, can reduce costs while increasing power generation. As seen in the PV station in Zhoushan, China, high Mo5 can significantly lower labor, land, and BOS costs and reduce LCOE. Also, the application of high Mo5 in Qatar has proved to be a remarkable improvement in cost reduction. The advanced technology of the high Mo5 leads to optimal LCOE, which is the result of LONGi's exploration of every detail of functionality. New M10 gallium-doped silicon wafer can reduce the linear power degradation to 0.45% per year. Compared with the traditional welding technology, LONGi's smart soldering technology reduces the tensile strength of the cell by 20%, by reducing the distance between cells by 2/3. This technology achieved a 0.3% improvement in module efficiency. High Mo5 follows a mature and reliable design path, framed, tempered glass on both sides to ensure the load capacity of the modules, with no crossbeam on the back to the module that blocks reflected light to ensure continuous and efficient power output. In practical applications, the size of high Mo5 is suitable for the main 1-portrait and 2-portrait horizontal single-axis tracking system. At the same time, it is perfectly compatible with the next generation inverters. The working current, including 15% bifacial gain, is kept within 15 amps, without the loss of current generation. Standardization, perfect adaptation, cost optimization, and high efficiency leads to optimized LCOE that enables high Mo5 to be one of the most valuable products on the market. The high volume production of high Mo5 is ready. By first quarter of 2021, global supply is expected to reach 13.5 gigawatts. The new HIMO 5 joins the Longi HIMO family, bringing in a new PV era with ultra-high value.
Thank you for the video. Hello and very good afternoon. Attendees joining from India, very good evening. This is Sangeeta here, and it's my pleasure to welcome you all on behalf of Solar Quarter and Longi Solar to our webinar on PV microgrid with energy storage, best practices for an optimized hybrid power plant. I would like to hand over the session to Mr. Daniel Goldstuck, who is the head of energy storage and microgrid services from Solar Group, to take the session forward. Over to you, sir. The screen is all yours.
Thank you very much. Good afternoon, ladies and gentlemen. My name is Daniel Goldstuck. I run the Energy Services Division for the Solar Group, a vertically integrated energy services company that develops, finances, and builds energy assets across Southern Africa and the broader African continent. All our speakers have extensive track record in the Southern African energy sector, and it is a privilege to be moderating this session today. To kick off, I'd like to ask our speakers to introduce themselves for between 2 and 3 minutes, and possibly share a presentation displaying their companies and their experience. And I will have a few questions thereafter before opening to the topic. So starting off, going from left to right that I see, Kalayan, if you could kick us off. Kalayan, apologies, your mic is muted.
Sorry. Okay, I'll start new. Okay, so where were I? Okay, my name is Kalayan Dimov. I'm CEO of SolarMG. SolarMG is a company which manufactures lithium-ion batteries here in South Africa, in Cape Town. We do from mechanical engineering, electronics, BMS, and we develop a software which monitors all our batteries and basically allow us to support better our clients. Our current production is about 250 megawatt hours a year, and we are planning to upgrade it to 500 megawatt years throughout the next couple of months. Thank you so much.
Thank you very much. Kevin, can you take us through your company, Longi?
You just open up the presenter view. Okay, it doesn't seem to want to work right now. Okay, so yeah, I've been in the, I'm a qualified electrical engineer. I've been in the solar module manufacturing space now for since 2008. Also done some EPC and project development work. So quite a lot of exposure in the South African market as well as Middle East and Africa. And then also been heavily involved in industry associations. So in the early days, setting up Sapphire in 2010, MESIA, Middle East Solar Industry Association, so the last couple of years, and then also in the African, AFSIA, the African Solar Industry Association as well. Thanks.
Thank you very much, Kevin. Victoria, will you please introduce yourself and Ilam?
Hello everyone. Very happy to be here today discussing this interesting subject. I'm gonna share my screen as well. Yeah, I've got 2 to 3 slides to show you. So yeah, I'm Victorian, sales manager here in South Africa for Illum Energy. So I've been basically originally kickstarting the activity of Illum, particularly here in South Africa. But I've been working with Illum here on that market for the past 2 years. So some quick facts about Illum Energy. So Illum Energy is a global company, but it's originally a French company. We have offices in Paris. Most of our people are in Paris, but we've got also people in Casablanca in Morocco and in Cape Town, of course, here. One people also in Mumbai, and will soon open new offices in Sao Paulo in Brazil and in Singapore. Illum Energy is expert in monitoring and control systems for microgrids, or what we sometimes call hybrid systems. We are reaching the 300 projects all over the world, lots of them, of course, in sub-Saharan Africa, but we're working in more than 40 countries. And yeah, our main clients are the solar EPCs, solar installers, but obviously being at the center of the microgrid systems and management, we obviously need to work with the different players all around and the different devices. And yeah, we have activity on different type of applications, lots of rooftop solar, CNI projects, but also microgrid in the sense of, for example, rural electrification projects. But we also do larger stuff, utility scale projects, grid-side PV power plants. So that's our main activities. And yeah, I just wanted to basically focus on one point that is important for us is our compatibility with all the main players on the market. Obviously, being, like I said, controlling the different part of the microgrid and being really the last layer of that kind of systems. It's really important for us to be first compatible and to have nice relationships with all the players around us. So don't hesitate also to ask and to contact us if you want to check the compatibility on a specific project. So yeah, that's it for me.
Thank you very much, everyone. I think those are some great introductions to your companies and the topic. I want to ask a couple more targeted questions before reaching into the broader presentations. So, Kevin, a question for you. We've been speaking for some time. Familiar with your background in the industry. What portion of your sales of solar modules are you seeing go towards microgrid or hybrid projects versus the utility scale or the grid-tied rooftop systems that we're reasonably familiar with?
Okay, so I think it's a difficult question to answer specifically, and I guess it's largely depends on your definition of hybrid. So I think we've gone through this quite a big cycle, the early days of rural electrification and proper hybrid solutions, off-grid, mini-grid type of applications. The industry then growing, a lot of property developers and commercial industrial clients installing solar in order to reduce their electricity consumption for various reasons. And I'd say the last sort of three years or so, I would actually classify the bulk of the business as being hybrid solutions. So I'm still installing grid-tied solutions on commercial rooftops. However, hybrid in the sense that they all have some kind of diesel integration, controller integration for security of supply. Some of the new installations are starting to incorporate batteries, things like load shifting for that security of supply during load shedding, bill optimization. And, a lot of the older installations now starting to incorporate solar storage solutions as well. So, and then the utility space in South Africa has been pretty slow. So I think we've only got about maybe something around 200 megawatts in utility scale projects in South Africa.
Thank you for that. And then just talking about integrating with storage, a question for Kalayan, you've been selling quite a large number of megawatt hours of batteries into the market over the last few years. What are your main business cases that you're exploring with your clients?
Yeah, thank you, Daniel. So, did I unmute my microphone? Yeah. So, on our side, so basically, the movement now goes towards microgrid. So we started very strong residential market in the last 7 years, and now it seems that only 50% of the batteries go into the residential space. Of course, the residential space is very important for us because it makes much better financial sense for the small client because the prices are quite high, and also load shedding. And the market on the small hybrid and off-grid inverters is very well developed, where the commercial part, it's coming now, I think, from this year. So we already implementing a number of completely off-grid plants into Africa. And also now the commercial sector, like shopping malls and private farms, are going into more like grid-connected energy storage systems, with tendency to get into the off-grid space, which is a bit more complicated on a 500 to 1 megawatt sites, what we discovered. So there are not too many options there, but we are testing also with all the PCS manufacturers, and it seems that the first couple of projects will go completely off-grid soon in the megawatt hour space. So yeah, I see a big movement into the basically off-grid Africa, some village rural electrifications, and the commercial sector in South Africa, like shopping malls, hospitals, etc.
Thank you very much for that. And it's quite a number of complex business cases and complex applications of energy storage products. So I think Victorian, as a supplier of the controller, this becomes quite a critical component in the overall project. What is your process to map out the use cases for the client and ensure that the controller delivers on the expectation?
Yeah, exactly. No, that's a good question, and it's really at the center of what we do and our business, because it's really hard, like Kevin said, or Kaloyan, the applications can really vary from one side to another. We see, of course, like load shifting, peak shaving applications. So it's really important to try to map those different stuff. The chains that we have at Illum, and especially on that sector and application that is just actually starting to boom. So not at the moment, not a lot of guys that actually have this expertise on building microgrids. The chance we have is that we already have like several references, and so we use those references to try to define use cases and try to identify some patterns. And then in terms of the process itself and how Illum is doing it to actually exactly achieve what you said, and actually keep the client goals, is that at the beginning of a project, in every project with storage, our team of engineer will really like dig into the technical details of the project and go over all the client specification and needs, and they will establish what we call on our side the technical specification document, which is basically a document, and a technical document that will state the controller behavior. So really, like in details, the control loops, the different operational modes of the controller, and basically that document is built with the client. to make sure that we understand what his needs are. And of course, upon validation of that document, we will move into product development. But yeah, that's really what we use to make sure actually that we kind of achieve what the client wanted to achieve originally. Was he like installing battery for stability, or to actually charge the batteries when the tariffs are low, and then sell the energy to the utility when it's like peak hours. So no, definitely it's important. And in terms of process, we making sure that before developing the product, we'll agree with the client on really what the controller will do and how he will actually do it.
That's great to understand your process there. I think that also just leads nicely into the headline topic, the actual best practices for optimizing hybrid systems. Could each of you outline your process to identify opportunities to maximize benefits and returns to clients? Kalayan, I'd like to start with you again. Apologies, Kalayan, you're on mute again.
Sorry about this. I apologize. So for us as a manufacturer of the lithium-ion batteries, it's very important that we work with PCS manufacturers, as well as companies like Elm Energy, to make sure that the battery system works as it's supposed to, and there are no expectations. So from our side, we try basically to optimize the communication between different groups and make sure that our batteries perform also as the client expects.
Thank you for that. Kevin, would you like to talk us through your process to optimize the business case and the hybrid business models for your clients? You're on mute, Kevin.
I think for the module guys, it's a slightly different process, and I think especially when you start to look at some of the bigger power plants, there's quite a lot of talking points to this. So it depends on who you're actually talking to in the value chain, whether it's the financier, whether it's the owners, engineers, or technical advisors, and the end customer. So I think there's three processes. First of all, the lenders want to see bankability, and bankability talks to financial stability of the company, technical and quality criteria, and then quite often the other scale of this is what is the cheapest cost. So let me just share this, and I'll talk through some of those points. So LONGi is now the biggest module manufacturer in the world. It's not moving forward. Let's try that again.
We can see your screen. We can see the.
So part of our DNA as a company is very much in terms of technology. So we, as the end of last year, we've invested more than $1 billion in terms of research and development. So that really makes us a leader in this particular aspect. So as I said, technology is really one of the fundamental aspects that we address. As a company, I think the biggest value proposition we offer here is in terms of the technology. We slightly differentiate ourselves in terms of using gallium doping. So this has some benefits when it comes to things like LID, light-induced degradation, LETID, light and elevated temperature-induced degradation, as well as the annual degradation over the 25 or 30-year period, depending on which product you're using. So what we talk to here is that by minimizing those degradations, especially important for hybrid plants, we're ensuring maximization of energy yield. So this will ensure faster charging of batteries and better plant performance. Just in terms of quality, this is another important aspect, and this is something that's close to my heart, is quality and reliability. So I think apart from the bankability, this is probably the most important aspect, and something that we focus on quite a lot. You know, what happens if you look at various studies about 2 weeks ago, PV Tech, but something like DuPont does a lot of studies.
Kevin, it seems like we have lost you. If you could
talking to this thing about hello?
Yes, you're back. I think you had a signal. We lost you very briefly.
Okay, so the quality aspects are quite important. If you look at the various studies, quite a significant portion, 25 to 30% of plants are underperforming for various reasons. A lot of that is on the quality of the modules themselves. So by focusing on quality and reliability specifically, you know, we ensure that the modules will last that 25, 30-year period that they're warranted to produce power. So these are very important aspects. If your modules start failing, you know, after 6 or 8 years, this has a significant impact, not only on the plant performance, but on the levelized cost of energy as well. So talking to the lenders, bankability, you know, across various metrics, whether it's Altman Z scores, the PV Tech module pyramid, Bloomberg New Energy Finance, we have been shown to be the most bankable module company. Just in talking to the technology, a couple of new records that are recently announced. So as I mentioned, by focusing on technology, improving efficiency and performances, we're making sure that we are able to offer a reliable quality and bankable product that is best going to suit the solutions for our customers. Just moving forwards, our main focus now is moving into N-type technology. So I think what we see there is that LONGi is leading that technology into, leading that transition into N-type technology. So I think from our point of view, what we're doing is leading our customers through this process, trying to educate them into the important aspects, but not only talking to those aspects, but supporting them as well in terms of actually executing those projects, both from ensuring energy yield, that the simulations up front are correct, that the energy simulations are done properly, right through to assisting with on-site quality criteria to make sure that the product that is finally delivered meets the client's expectations.
Excellent. It sounds like great achievements that LONGi is making in new technology space, and that process to walk your clients through their projects is quite intensive and involves a lot of detail. I think then Victoria, on the microgrid controller as a tool to really extract value for the project. I'd be please, can you introduce us to your methods of optimizing and taking that value of the project?
Yeah, sure. Thank you, Daniel. Yeah, definitely. I wanted to dive a bit more on actually what our controllers are doing, and especially the features that such control system can actually achieve. So I'm going to share again and come back on my presentation. All right. So yeah, I wanted to give to the people a bit like an overview of the different features and what we can actually achieve with that kind of systems. Because also, I mean, lots of our work is also educational because obviously the stuff you can achieve with an energy storage system will vary a lot, and yeah, most of the time the end client or even the EPC is not super sure or how he should actually control his microgrid. So on our side and for Illum, we differentiate two type of projects where we'll have actually battery systems. So obviously the grid tied systems, systems that are connected to the main grid, and on this type of use cases applications, our controller will actually switch between two operational modes. So of course the grid tied mode when the grid is connected, and sometimes also islanded mode, as we know it well here in South Africa, for example, with load shedding. But obviously it's the case of grids in Africa and then pool grids in general. So in grid tied mode, you will really be able to get the value of the battery with different features that you will be able to actually implement. So such as load shifting, load control, so peak shaving, like we said, definitely charging the battery when it's off peak, and then using the battery system when you're in peak hours. You can do also some load control. That's what actually Illum is doing on several sites. The controller is actually able, for example, to do breaker control, so to open some breakers depending on the conditions on site. And on islanded mode, of course, always ensuring minimum genset loading. To reduce your fuel consumption while keeping your gensets at a minimum loading, to make sure that you're actually not using it in a bad way, and of course maximizing the solar penetration. And on sites that are totally off-grid, so obviously we do the same kind of features that the controller will achieve when we are in islanded mode for grid-tied projects. So always minimum genset loading, maximum solar penetration, and we can also implement, and that's also the value of having energy storage systems on a project, is that you can really achieve nice stuff in terms of spinning reserve optimization. So really the goal always is to try to optimize and get obviously the maximum penetration from the renewable, and of course save fuel, save money. And you can actually also, something that is important, you can actually also use your battery system as the grid forming unit. That can be also helpful in the case of grid-tied system. But as you know, when the grid is not here or when the grid goes down, another grid forming unit need to actually set the references in terms of frequency, voltage. So you can, obviously most of the time you achieve that through diesel generators, but you can do that also through energy storage system and batteries that can be actually grid forming units to here again achieve what we call diesel off mode, so totally skip the diesel part and try to only rely on PV and battery. And in terms of product, really concretely, for us, it means different type of products. That's really one of our core values, to have solutions tailored to each one of the applications. And that's also the way we are able to actually provide cost-effective and efficient solutions, depending on the size of the site, on the complexity of the control the client want to achieve. So definitely for us, it means having different kind of products that will always fit the needs of the client. And with all of those products, we are putting also a lot of effort into our products being products that are actually easy to deploy. especially the period we know now with COVID and stuff, and in general, people want to reduce the interaction on sites and want to obviously spend less time as possible on site, right? So we actually have with all of our product a really nice what we call configuration interface. So it's a local platform with which actually the EPC and the technical guys on site will be able to really configure everything, configure the different devices, choose the control strategy, set up some values like the percentage for the minimum genset loading and stuff like that. And obviously the engineers from Illum can access, once the internet connection is set up, they can access remotely to the controller. So they will be able to follow each step with the guys on site and to troubleshoot if needed. But yeah, we really want our product to be EPC friendly and to reduce the time on site to actually deploy. And on top of that local interface, of course, we have the monitoring system, which is a web platform on which obviously the client will be able to have his portfolio and really have an overview on the different sites. Here again, we want to bring standardization that the client doesn't have to actually use each time they switch devices, they have to use a different monitoring platform. We really provide something for him to be able to centralize everything on one platform and obviously, yeah, just reduce the time he's spending to train teams or stuff like that. Yeah, so that's some of the screenshots of the monitoring platform, but I'm going to be quick on that. You can edit some alarms remotely. And yeah, I just added at the end meaningful reference. It's actually a project we did recently in the Comoros, where basically the project was to integrate a Tesla system with, of course, solar PV, and it was also a grid-tied project. Quite complex because the strategy and the switching between grid-connected mode and islanded mode was a bit complex. But that's the type of application and sites where we bring value. And sometimes that's where we are actually doing stuff that the other systems or devices can't do, because obviously they're not centralizing the data and they maybe don't have the expertise to be flexible enough on that kind of strategy. So yeah, just wanted to mention that nice projects, and yeah, that's it. And yeah, in a nutshell, it's really important for us to be flexible and to understand the client needs, especially for those applications with batteries, where here again, people are just starting to understand what they can achieve with that, and it depends a lot on the grid constraints and stuff like that. So we really value the fact to be flexible.
That's really excellent. That's really excellent to understand all three of the products that are on the market, between controllers, the microgrid controller, the modern lithium-ion batteries, and a new technology and higher efficiency solar panels. The technology is here to enable whole new business models and whole new ease of deploying energy solutions to clients. And we're certainly seeing as the solar group an expanded business case between, whether it's between just batteries for backup against load shedding, complete off-grid solutions for diesel avoidance, and an emerging commercial and industrial market for energy tariff optimization. It's I think it's quite exciting. It's a whole new paradigm of energy solutions. I've got a couple of questions my side, and then we'll open up to questions from the audience. I've seen quite a few good questions are coming in. I wanted to just one of the largest challenges in executing on energy projects is walking the client or the utility down or through a journey of getting them comfortable with your products and with the end solution, so that the client knows that what is being delivered is what is asked for. What are some of the frequently asked questions that you encounter, and how do you allay those concerns that that materialize? I think I'll go with the same order. Kalayan, if you could let us know how some of the questions that you encounter on your products.
Yeah, thank you. Thanks, Daniel. So on our side, mainly is questions are about the life cycle of the batteries, reference sites. We work mainly with distributors and then with the EPCs. So technically directly with the EPCs, and then commercially mostly with distributors. So we have to also look project specific to make sure that all the parameters of the battery are taken care of. The C rating, which is the maximum charge and discharge rate of the battery. So most of the times the battery is designed a little bit too small compared to the power that needs to produce. So we need to make sure that expectations are met, and then showing our new clients how the batteries are manufactured, the welding process, the testing process of every single module, and then basically showing references from other EPCs where existing the biggest what we have currently is 2.8 megawatt hours as a single system, and many further commercial are coming, but we always need to give some references. Thank you.
Kevin, will you take us through some of the questions you get asked?
The first point is always cost. So what's your price? It's the first question that everybody always asks. But I kind of alluded it to in the presentation is we're trying to educate customers that price should be probably about the 6th or 7th question that they should be asking. Obviously, bankability talks to a number of different points, not only the financial situation of the company. So we've seen quite a lot of, and this is globally, it's not just a South African situation. I've seen quite a lot of power plants where modules have failed within the first 5 years. So specifically when you're getting to larger projects, this has got quite a significant impact on a project. Not only do you have the downtime when those modules are not connected or not producing energy, but how does the company actually deal with the warranty process? Are they actually going to be able to? Will be in a situation where they pay? So that's always a talking point. But bankability also lends itself to the technology that you're using, the quality. Not only looking at the IC testing, but looking at some of the advanced or durability and reliability testing with labs like PV Evolution Labs or the RETC labs in the USA. Both have got commercial tested, and they publish the results quite on an annual basis. And I think just walking through that process and making them understand some of the risks that all modules are not created equal, and there are other considerations that they need to be thinking about as well.
Excellent. Thank you for that. And Victorian from Elam, what are the questions that you get asked? I imagine quite a number given the critical nature of the controller.
Yeah, no, exactly. I think on the side of Illum, and also being kind of the last layer of the system and of the microgrid, mostly the first question is about compatibility, right? Because obviously we need to communicate with different devices on site, and it's really critical that this communication is actually possible between the different devices, and that our set points or our orders are applied correctly. So mostly the compatibility. And yeah, we try to answer that by really being what we call hardware agnostic. So mostly to get a bit into the details, we use Modbus communication protocols. So most of the players in terms of PV inverters, battery PCS, genset controllers, or other stuff, third-party meter, third-party weather stations, they will also use at least Modbus RTU or Modbus TCP. So obviously we try to answer that question first with our references, because obviously having lots of sites now, lots of the main PV inverters models or battery PCS models we've been integrating already and having sites that are smoothly working. And then it's just like basically reassuring the clients on the fact that our team has been studying the different devices and validating the protocol of communication. So obviously our list of compatibility is expanding every day, right? Because we are always working with different sizes in terms of PV inverters and stuff like that. So yeah, that's really the main issue for us and the first question. And that's why also we try to build an ecosystem around us. So not only talking to the solar EPCs, but reassuring the client that actually locally we know the local guys that will sell the PV inverters or stuff, because we can actually being more confident if anything happens on site, we'll be able to jointly work with those guys to move forward, even if it's not an issue particularly in the scope of the controller. But yeah, just like bringing the discussion forward and knowing those local guys around us, we can definitely reassure the client on the fact that the product will integrate smoothly.
Excellent. Thank you very much for that. I'm going to switch over to some of the questions from the audience members. I'll try group a few together and do focus on some of the selected questions. The first two that come to mind around the costing of the batteries. This probably best answered by yourself, Kalayan. A question from Batu on essentially what is the storage cost per watt hour and per kilowatt hour, and then linking that to a later question, how will batteries become cost competitive with in their various applications with grid tariffs?
Yeah, thank you so much. So the batteries, so I'm basically in the business in the last 7 years. So the decreasing of the cost has been very linear. So with about 10 to 15% per year. And in the last 1 year, even the components get more efficient, similar like the PV panel. So we are achieving now almost double the energy density with the cells which we use because of the efficiency. The cost slightly rise up, I think, on the PV panels as well. Maybe Kevin can mention due to the transport cost. So the world transportation is getting a bit more expensive, but on our side at SolarMD, we because of our own scale of production and optimization, we managed also again to decrease the cost also in the last couple of months. So I'm very positive that the cost will go further linearly down, maybe not so quick as some people may hope, but I'm confident that it will be in the range under 100 USD per kilowatt hour for sure. But also on a probably on the full system as we optimize. Let's say if if the projects are built on a factory scale, let's say a 2 megawatt-hour container is built every couple of hours, then also on the battery system scale, you can achieve much better cost.
Excellent, thank you. And then Kevin, a couple of questions for yourself. Perhaps more broadly, what do you see as the future of hybrid projects in Africa? And then a question related to essentially rural electrification. How do you see these technologies enabling access in marginalized areas? How do we essentially accelerate energy access so that everyone can be connected?
Yeah, thanks for that. So in terms of a South African context, I would say the hybrid power plants, the two biggest growth sectors as the cost of storage comes down is definitely going to be the light industrial commercial type of premises where they're mainly looking at security of supply. So the current situation with the utility does cause problems. Especially when you start looking at light commercial, light industrial. For example, we had a situation where a company that does printing, or even guys who are doing dairy production, as soon as they have a load shedding event, suddenly you've got printing presses, injection molding, or for example, a yogurt factory now they don't have the loss of production from downtime, but now they also have to go clean all the machines. So that 2-hour load shedding event could actually cost them 9 or 10 hours till they get back up to full operation again. So there's huge losses there. So that energy of security is pretty important. And then of course, with the lifting in South Africa of the cap to 100 megawatts, I think where we're going to start to see a lot of the business developing is embedded generation within the mining sector. I think that's a massive opportunity. Rural electrification in the rest of Africa, there's something like 600 million people in Africa without access to energy. So the type of applications you're seeing is, particularly in East Africa, they're quite active with AMDA, Microgrid Development Association. Typically speaking, they have a model where they do hybrid power plants in a community, and then through a metering process they sell to the community, and that's heavily subsidized to offset the cost, and also when you consider the cost of actually building grid infrastructure. So quite often the utilities and government are getting involved in those type of projects. But the third part that we see quite active in rural electrification is either where you have telecommunications towers or clinics. So quite often what will happen is a company like Vodacom or MTN will go and build a tower in a community. Obviously they need revenue from the data. So quite often they will build a solar solution for their tower and provide excess energy to the community. And a similar thing is starting to happen in the health sector, where you need energy for clinics, especially for vaccines and vaccine fridges and that type of thing. So once again, there's quite a big drive to electrify the clinics and provide excess energy into the community as well, just to ensure that they're getting buy-in.
Thank you. Yeah, it does highlight the applicability across a number of sectors on the continent that storage and hybrid business models are appropriate for. Then there's quite a lot of questions coming through on the microgrid controller. So these would be for yourself, Victoria, just to highlight a few compatibility. How do you integrate with a number of different suppliers? Do people need to replace existing equipment on site? And what do microgrid controllers typically come with? Automatic transfer switch, or that's the responsibility of the EPC. So just to focus on a couple of those.
Yeah. Also on the different points, first on the compatibility, obviously you don't need to replace what you already have on site or what you plan to use. Obviously the clients and the EPCs, they sometimes are preferred suppliers, or also depending on the projects and of course the price. So we obviously adapt to the configuration that will be chosen by the solar EPC. So we are, like I said, compatible with most of the brands, and really using Modbus communication protocol. It's quite easy for us to communicate with the different devices on site. In terms of what we need to provide on the side of Illum, so obviously the controller itself, so the hardware, but also depending on what you want to achieve in terms of control, we sometimes provide additional meters. So for example, for applications that are grid tied, we obviously need to monitor the grid. So to get measurements from the grid connecting point. And sometimes on some systems where, for example, we don't have compatible genset controllers, we use also power meters to monitor the generator's output. So that's kind of what we need to provide with Illum controller, but that's mainly it. So the scope is really, and our job is really to integrate between all the other devices. I remember the question about the ATS. So no, the ATS is not on the scope of the controller. So actually an ATS need to be equipped on site. We don't really deal with the switch between the different power sources. What we do is that we detect that a source is online. So for example, when the genset is coming online, or the batteries, and then we apply a different control strategy or stuff, but we don't actually deal with the switch itself. So no, you need to have an ATS on site. I don't know if I missed one point maybe. I'm not sure.
Likewise, I think perhaps I see we're coming to the end of the hour. I think it's been quite interesting pursuing hybrid projects from the 3 different angles or 4 different angles, from battery supply, solar supply, controller supply, and then ourselves as an integrator. I think I'd like to go to closing remarks of essentially, what are each of you most excited for now that battery price costs have come down and the controller technologies have matured? What are the most exciting things on your respective horizons? I'll go back to yourself, Victorien, and take from there.
No, really, we are really excited ourselves to work on more and more energy storage systems, because it's really the way forward. If you want renewable to actually have a better penetration, and actually it's the way to actually get the best of the solar itself. So solar systems and what we call purely PV diesel integration, it's quite known. Lots of people working around that. So yeah, it has been around for a long time. Now those new systems with solar PV, diesel, and BSS systems, or sometimes only solar and energy storage systems. It's really the way forward, like you said, with the price decreasing, and also with the technologies, and then quite the complexity of what you can achieve with that. Definitely, we are really excited to do more projects to bring Also stability and reliability to more people. It's not only just to have like fancy systems or whatever. It's also ready to actually improve electrical grids.
I'm unfortunately I'll cut you short
Sorry
there.
about
I'd like a comment from Kalayan and then Kevin to close.
Yeah, on my side, I'm the most excited about the off-grid sector into Africa, systems between 50 and 100 kilowatt up to 500 kilowatt hours. That's what I like to to see my product going into electrification of rural communities, and everything else we do it as well. Yeah, thank you so much.
Yeah, I think from my side, from a South African context, the fact that the cap on the generation license has been increased to 200 megawatts, I think that is a fantastic opportunity for our industry specifically. But I think for me, the most exciting thing is that as storage comes down and a lot of these controllers start to become a lot more sophisticated, let's say, what it is going to start to do is facilitate the transition into smart grids, into virtual power plants. And I think that is probably the most exciting sector for me.
Excellent. I'd like to thank yourselves as our panelists. It's really appreciate your time and your insight and experience in the sector. And a thank you to First View for hosting all of us. And of course, a big thank you to the members of the audience for attending, for your time, and for some robust questions.
Thank you, and thank you, Daniel.
Thanks, Daniel. Thanks, everybody.
Thanks, everyone.
Bye-bye. Thank you, everyone.
Bye.